Yep. Sure did. I finished them. Posted them yesterday. Okay, so the question of the day was, how is the inclined plane different than all the other motion maps that we've done? How is it different?
One shows how the ankle moves all over the place, and one is just horizontal.
Remember how, and that's a good one, Jay. I like that. Remember how we did them before, and what we did is our X and our Y axis was here? But then when we were actually showing the motion map of the object, we actually had our normal this way and our gravity this way. Do you see this inclined plane? Where's my normal? That way. So it's not parallel to each other, is it? But it kind of is. It's just not straight up and down. So the answer to the question was that. Everybody got their calculator open? Everybody good? Who needs help? Who needs help?
Hey, it won't let me do my thing on the tablet now.
Right, man. They won't.
It won't let you do it.
Open up your calculator. Try to find it, baby. Okay, so yeah.
This clear is not for me.
It's okay. You're fine. Just go to your main screen. There you go. And the little bunny. There we go. Do you know where your calculator is, baby, or do you need me to help you? Mm-hmm. Yeah, you go. You're good. Okay, so we're right now on page 136. So on page 136, what it did is it kind of showed us they had three different types of force. A was going up, B was going down, C was going to the right. So what they ended up doing is they ended up combining all three forces together to make kind of a triangle. When they drew the triangle, that showed equilibrium. Equilibrium is where something is all equal. There's not one force over another force.
What is supposed to be missing?
Ma'am?
What is supposed to be right there?
What is what supposed to be?
Well, you got example problem, supposed to be example problem 5. What's that second picture?
Is a picture of the vector that they have. So if you'll give me just a second, when I get there, I'll explain it to you.
Okay.
All right, baby, is that better?
Yeah, because
Because this is where I'm at right now.
okay.
Okay, so what they did is they said, all right, so if you take all these forces, it's equilibrium, we're drawing a triangle. So then they showed us a girl that was going down the slide. With this girl going down the slide, it was showing her force diagram, her force net, and her acceleration. And remember, when you're doing a system, what do? Draw a circle around it. This here is showing your X and your Y vectors. This right down here at the very bottom where this thick arrow is, this is telling me my force normal for her. So this is my object, which is the girl. My force gravity, though, is going down in that direction. And what they did is they showed you where your X and Y axis was, ma'am. And then it also showed you the angle here.
I want to talk about that. I want to talk about the one below.
Yes, ma'am, I'm almost there. So then that one was the example of the girl on the slide. So if you can, open up your textbook. Turn in your textbook to page 139. So now you have to have your textbook open. Don't worry about having your ISM book open because you can see it on the board. So example problem 5 on page 139 shows, it says components of weight of an object on an inclined plane. They say it's 562 Newton crate is resting on an inclined plane at 30 degrees above the horizontal. Find the components of the crate weight that are perpendicular and parallel to the plane. So what this is, ma'am, is this is my attempt of drawing the pictures that are on there. Do you see the pictures?
So 139.
Uh-huh. Do you see the pictures, ma'am? Page 139? It's okay. So it's showing you the angle of the box, and here is where they're showing you the X and Y axis. So when you're doing a problem, you're drawing an example, you're drawing your vectors, and then you're drawing what your equations
So what
are.
confused me where you got a little scribble up.
Yes. This right here,
Yes, ma'am.
what this is here is it's showing this vector here and this vector here, and I'm squaring it off to show how far that vector is. Okay? Does that answer your question, baby?
Yes, ma'am.
Okay. So based on the problem, they said that her force was the box was 562 newtons down. They said that the angle was at 30 degrees. And then they said also, we have to find what the other angle is, because there's two. Now, let me ask you a question. Why they take 270 from 30 to get 240? Because that complete angle is 270, right? And they had to take the 30 away because that's what they told the angle was. So my new angle is 240. So I'm going to use that 240 in my equation on the right-hand side. So to do this, it's asking me what is the force in the x-axis and the y-axis. And that's what this is over here. So it says the force of gravity on that object of x. It equals the force times gravity cosine angle. All right, so let's see if we can do this equation. Remember, our main thing is to know what the words mean and know how to do it in the calculator. So let's go ahead and get our calculator. Yep. So first of all, you need to make sure you're in what mode? No, because there's a degree here, right? So let's change this to degree. I'm gonna lighten this up so you can see it, because I don't care about there. So the first thing we're gonna do here is we're gonna change our mode. So change your mode to degree. Has everybody changed their mode to degree? Jeffrey, have you changed your mode to degree?
I don't know how to do that.
I just did it up here. So what you do, go hit the mode button, ma'am. Are you there?
Yes, ma'am.
And you should look, and you should see what I've got here. Do you see the same thing I've got up here? Do you see that?
I got all that stuff.
Yes, ma'am. So go down 2 times, go over 1 where it says degree, and hit enter. You got it?
It's blanket on degree.
Okay. So now clear. Yes, Joe, you did, didn't you? So what I want you to do now is put this equation in.
Which one?
The one that's right here, 562 cosine 240. So, open bracket, 562 cosine 240, and hit your close bracket and hit your enter. What did you get? Negative 28, 1, right? Okay, if those of you who got that, go ahead and do the next one.
I got that, but
But what?
this is how we, once we do it, we hit 562, then we get the cosine, right?
Yep,
And then that.
yep. You're good. You got 281. Okay, so now what I want to do, go stand back there if you need to, babe. What you need to do now is we're looking for the y-axis now. So remember, x-axis, we're using cosine. Y-axis, we're using sine. Remember, sine is right beside cosine, isn't it? It's right there. So let's do the same thing, 562, and then we're going to do sine, and we're going to do 240.
So what we're doing now?
We're doing this one right here, baby.
Okay, let's just see this.
Yep, open bracket, and 562, close bracket, and then you can do sine, and then you can do 240, and close, and hit enter, and you should get a negative 486 point blah, blah, blah. And I made it 487. Are you good so far?
I didn't get that.
I got her, baby.
No, you forgot the picture. You probably didn't change did you change it to the degree mode?
Go to your mode. Nope. Go down to inside of. Okay, so that is the practice problem.
That's why you didn't get it.
Yep. If you change it into to mode, you'll be okay. So let's look at the next question.
Hope you would see.
So this one here on 33, the only thing it's asking us to do is just diagram it, right? So it says, an ant climbs at a steady speed up the side of an anthill. If the incline is 30 degrees from the vertical, sketch the free body diagram of the ant. So here's my ant. The only thing I'm going to have is force gravity coming down, 60 degrees. That's diagramming it, right? And now over here, I'm going to do my force diagram. He's on an inclined plane, is he not? So since he is, my force normal is going in that direction, opposite of where he's at. Here's my ant. Force gravity is in the opposite direction. But then I have your friction force, remember that? Goes in that direction. So the only thing it asked you to do for 33 was just graph what was going on with the vector and also with the force. Everybody good with that one? Perfect. 34. So let's see what it says. It says, Ryan and Becca are moving a folding table out of the sunlight. A cup of lemonade with the mass of 0.44 kilograms is on the table. Becca lifts her end of the table before Ryan does. And as a result, the table has an angle of 115 degrees with the horizontal. Find the components of the cup weight and the parallel perpendicular to the plane of the table. So let's get this off this picture. Okay. So what we're going to do here is we're going to do mass times gravity, and then we're going to do sine of our angle. It told me in the paper, on the book, that is 0.44 kilograms was my mass of that, right? Gravity is always 9.8, and then our angle is 15. So the only thing we're going to do is we're just going to take our mass times our gravity, sine 15. So put that in your calculator and see what you get. So we're doing this equation right here. So in your calculator, you're going to do open bracket, 0.44, close bracket, open bracket, 9.8, close bracket, and then sine 15, close bracket, and hit enter. 1.1, and that's what I got there. But the thing it was asking us at, it was asking us for one other thing. Since we did sine, what do you think we do next? Cosine. So do the exact same thing and do the cosine, because you're doing the x and the y variables. So 0.44, 9.8, cosine, and it's 15. And I got 4.16, which I rounded up to 4.2. Do you understand how I got that? Everybody good? Okay? So now what we're going to do is we're going to turn our page and we're going to go do question number 35. Thank you, babe. 35 says Fredo has a mass of 43 kilograms sliding down the banister of his grandfather's house. If the banister is an angle of 35 degrees with the horizontal with the normal force between Fredo and the basket. And that. So let's look and see what I did. So his mass was 43 kilograms, right? The angle was 35. We're going to do the same thing again. Mass times gravity cosine angle. So let's go ahead and do that. Why are we only using cosine instead of sine this time? Is because the measure is in the x-axis. Correct. So then I'm going to go and say, all right, I'm going to open my bracket. I'm going to open my bracket, and that's 43.0, 9.8, and cosine 35, and I'm going to hit my enter key, and I get 345. Did you get 345?
Mm-hmm.
Fantastic. All right, let's change the page to the next one, please. So let me read what it says in the book for y'all, because I see you're writing. So it's okay. So example problem 6. I understand. I thought maybe 15 minutes was going to be enough for you to write all your notes before we started. Yes, ma'am, it is. I'm hurrying a little bit today, baby, so that I can give you the test. Okay?
You got a test to take, or?
We're going to take it in here. It's 1:03 right now. And I'm going to try to get it to you soon enough so you can finish it. Okay, so let's look. On page 140, it's telling me that Enco, who has a mass of 45 kilograms, is going down a slide at a slope of 27 degrees. The coefficient of the kinetic friction is 0.23. How fast did they go down the slide? 1 second after she started from rest. So what I did is I wrote down what her mass was, which was 45 kilograms. Remember that funny looking U and K is sliding friction, right? T is my time because it says it wants for 1 second, and it's asking us for acceleration, velocity final, and the angle. So what I did is I took the diagram that we have here, and I decided that it's 27 plus 270 to give me the 297. That's my angle. That's all I had to do was do that. So then when I'm talking about the y direction, I know the y direction is opposite, so it has to be 0. So then I need to find the x direction, and that's what I was doing down there. So with the formula that I'm going to use for that is gravity times cosine of my angle plus the sliding friction sine of my angle. So what I'm going to do is I'm going to do my 9.8 cosine 297, and then I'm going to add my sliding friction, which is 0.23. See, it's up here. And then I'm going to do my sine of my angle one more time. So let's see if we can do that with our calculator. So we're going to open up our bracket, 9.8, close, cosine 297. I'm going to close that. And I'm going to add 0.23, close, sine 297, and close one more time. So what I did is I just basically did everything I have here. The only thing I'm missing is when I finish my cosine, I have an angle. So if I hit the enter key, I got 4.24. Now, why did I get 4.24 instead of 2.4? Well, let's go up here and see. Do it one more time. Let's take that answer, and I add 0.23. And if I take that answer, and I sine 297, so I'm just breaking it down into separate ones, I get 4.16. That's still not right. So let's see. So we do gravity, cosine the angle, plus the sliding friction, sine of the angle. I wonder if I have it wrong.
You working too fast when you're doing this?
No. No, I wasn't. That's a good question, Jay. It is Friday, right?
Okay.
Well, for y'all it is.
They look like 1.05.
Was it easier 5 days a week
I was
to do all this stuff?
Yeah. I did it wrong. So the answer is 424. Please write that down because that's wrong. Because I did it twice and I still got the same answer. So the answer is 424 meters per second. Sorry.
So it's not the 2.4?
No, it's not. So then now down here for velocity final, we're going to do 0 plus 424, and we're going to times that by 1 second. And that answer is 424. Yep, that's correct. That's right.
What's that in that little corner at the bottom? I can't see it.
That's 1 second.
1 second. Yes, ma'am. Uh-huh. Okay. 37 is where we're going next. And I'm going to do 37, and that's where I'm going to stop. Because you will have the answer for 39, and you'll be good to go. So on number 37, which is on the next page, consider a crate with an incline. Example problem 5. Calculate the magnitude of acceleration after 4 seconds. How fast will the crate move? So here's the other crate problem that we did before, exactly like we did the diagram on the last page. We have our crate, we have our positive y and our positive x, and our angle. Here's my force diagram. On my force diagram, my force gravity is down here. My force normal is going in that direction. And then I'm looking for this force gravity here. Okay? So to be able to do that, I'm trying to find out what acceleration is. What these are these are 4 different equations that you could have used. So I'm not using that one. I'm not using that one. I'm not using that one. I'm using this one. Okay, so I just wanted to show you there's 4 scenarios for acceleration. So with this one, it says gravity, sine, angle. Well, I know my gravity is 9.8, and I know my angle is 30. So in my calculator, I'm going to do open bracket 9.8, and then I'm going to do sine 30. Close bracket. And I get my 4.9 that I have here. So if velocity final minus velocity initial divided by time final by time initial, that means that my velocity initial, time initial is equal to 0. So what it's asking us there,
It's 4.9.
no ma'am, it is what we have for acceleration right now, but the question was asking us after 4 minutes how fast we were going. So we had to find acceleration first, so that's what we did here. That's a really good question. So
I see you like on the other ones you boxed them, and I seen that one and you didn't.
yeah, I didn't, because the first thing that we did is we try to go and find out what our acceleration is so we can find our velocity final. So velocity final, we have to find our acceleration, okay, times our time final, and that's what we're doing here. So we're taking our number that we got, 4.90, and plugging it here, and it's asking us after 4 seconds, so we're just taking those two and we're just multiplying those. And we multiply those, we get 19.6. Questions? Fantastic. I will stop.